So this is a video on factoring polynomials. It's the chapter 11 notes for the Math 120 class. And so we'll take a look at all aspects of this factoring polynomials topic. Now, I have a basic flowchart that you can follow that will help you know what to do and when. So the first thing you want to make sure that you prepared the polynomial by combining any like terms and then putting terms in descending order from highest degree down to the number. So first you want to, after you get that prepared, you want to make sure there's no common factors. And if there's a common factor, you'll distribute out the greatest common factor. So we'll talk about how do you do that. Second step, if it's a binomial, then you'll check for either a difference of squares or a sum of cubes or difference of cubes. Pretty much most of the time, if it's a binomial, we'll mainly check for difference of squares. Then thirdly, if the result is a trinomial in the form ax squared plus bx plus c, where you could have A being 1 or A being any number you want, B being any number, C being any number. So if it's in that form, if it's a trinomial, then first ask, is 1 the leading coefficient? In other words, is A equal to 1? In other words, the polynomial starts with x squared. Here's an example, x squared plus 3x minus 10. If so, try to find factors of C, the last number, that add up to B. So in this case, I wanted to find factors of negative 10 that add up to 3. Now the factors of negative 10 are either 1 and negative 10, or negative 1 and positive 10, or negative 2 and positive 5, and positive 2 and negative 5. So there are 4 possible pairs, and so the pair that adds up to 3 is 5 and negative 2. And so that's the pair you want. So then you put it in the binomials, you go x plus 5, x minus 2. And if you FOIL that, or double distribute, you'll realize that you get the original trinomial that you started with. All right. Now the second way is if A is 1, then try the AC method. So we'll talk about that later. But if you don't have a 1 in front, if you have 2 or some other number in front of the x squared, then you'd have to use the AC method. And then last of all, if there are 4 more terms, try factoring by grouping, and we'll talk about that as well. Now, the first thing, factoring out the greatest common factor, let's take a look at some examples here. So let me get a pen to write with. All right, so in the first example, you see that 5 is a factor of both of those terms. So we're looking at 5x plus 45, and we see that 5 goes into 5x and 5 goes into 45. So what I do is I put the 5 outside, and then it's like we're dividing each thing by 5. So like I'm dividing 5x by 5, and I'm also dividing 45 by 5. So 5x divided by 5 is just x, and 45 divided by 5 is 9. So the answer is 5 times parentheses x plus 9. All right. In the next case, we have that 24y cubed minus 42y squared, and we want to take out the greatest common factor. Now, as far as the numbers goes, 24 and 42, well, you know 6 goes into 24, and 6 goes into 42. 42 is 6 times 7. So that's the highest number that goes into both. Now we'll talk about how do you handle if you can't figure out what's the highest number. but 6 would be, as far as the numbers go, the greatest common factor. Now, you notice in the first term you have y to the third power. In the last term you have y to the second power. So you can only pull out 2 y's. So we'll use 6y squared as the greatest common factor because you can't pull out more y's than you have. So distributing out is like dividing it by 6y squared. So if you have 24y to the third divided by 6y squared, well, 24 divided by 6 is just 4, so I'll write down 4. And then if I pull out 2 y's or divide 2 y's, y to the third by 2 y's, well, 2 of those y's cancel. You're left with 1 y. So we have 4y, and then in the second case we're going to divide by 6y squared also. Write this. So what is negative 42y squared divided by 6y squared? Well, negative 42 divided by 6 is negative 7, so I already have the minus sign there. And then y squared divided by y squared, well, that just cancels right out, and so you don't have anything left. So you don't have to put any y in there. So the answer is 6y squared times 4y minus 7. And if you distribute to there, you'll notice that it equals the original problem. All right, the third example, we have 60 and 132. Now, it might be difficult to look at 60 and 132 and decide what is your greatest common factor. So one way to do this is to break it down all the way into its prime numbers. So 60 can be broken down into 4 times 15. 4 can be broken up into 2 times 2, 15 into 3 times 5. So this is what we call the prime factorization of the number 60. 132 breaks up into 4 times 33. 4 again breaks up into 2 times 2. 33 into 3 times 11. So this is the prime factorization for 132. Now you could have broken that up any way you wanted. Eventually you'll get down to the same prime number factors at the bottom. It doesn't matter how you broke it. Like, for example, 60, we could have broken it up into 2 times 30. And then 30 would break up into 2 times 15, and then 15 into 3 times 5. So in the end, we'd still have 2 times 2 times 3 times 5. All right, now, the greatest common factor are the factors that you see in both of them. And you see that I see a 2, and a 3 in both of the lists of prime factors. So the GCF is 2 times 2 times 3, which is 12. All right, so 12 is the greatest common factor as far as the numbers go. Now I have y to the fifth, z to the fifth and z to the third. So whatever number's the lowest is what limits you. So I'm going to have z to the third as in my GCF. So 12 z to the third is the greatest common factor. And if I divide 60 by 12, you get 5. And if I take out 2 z's from 5 z's, 3 z's from 5 z's, you end up with 2 z's. So 5z to the second is your first term. And then if I divide 132 by 12, I get 11. And if I take 3 z's away from 3 z's, you have no z's. All right. Now notice the remaining numbers are 5 and 11, the same as the extra factors that we had that were not in the GCF. So that's a way to save yourself some trouble if you've already done this part of it. So anyway, the answer is 12z to the third times parentheses 5z squared plus 11. All right, next example we have is negative 9 a to the fifth plus 18a to the third minus 3a to the second. Now, obviously, 3 goes into everything, but because my first term started with a negative sign, I'm going to use negative 3 as my GCF for the numbers instead. And then I have at least two a's, so a squared. I have at least two a's in all the terms. So I'm going to use negative 3a squared as my greatest common factor. Now imagine dividing each of these by negative 3a squared. So if I divide negative 9 by negative 3, I end up with just 3. And if I take two a's and divide by two a's, I would end up with a to the third power. All right. And then 18 divided by negative 3 is negative 6. And a to the third divided by a to the second would be just 1a. Or a to the first, I mean. So the second term ends up to be negative 6a. And then if I divide negative 3a squared by negative 3a squared. Well, negative divided by negative is a positive, and you end up with plus 1. All right? So that's the answer. You've distributed out your greatest common factor, but you distributed out a negative of it because that first term is negative. There's a reason down the road why we want to do that, but that's a good practice. All right? Now the last example here is 2/5 b squared c to the third minus 3/5 b squared c minus 1/5 bc. Now notice everything has a fifth in it, a denominator of 5. So the book has some problems like this. So what you do is you basically separate the 2/5 and think of it as 2 times 1/5. The negative 3/5 could be thought of as negative 3 times 1/5. And the negative 3/5, I'm sorry, negative 1/5 is negative 1 times 1/5. So you have a 1/5 that you see in everything, and also everything has a b and a c in it. So my greatest common factor is 1/5 bc. And if you divide everything by that, you end up with, because you're going to take out that 1/5, so you just have 2b c to the second minus 3b minus 1. All right. So when you divide, this last term by 1/5 BC, you end up with minus 1. All right. Now factoring by grouping is really distributing out a common factor, but the common factor is a binomial instead of just a single term. So take a look at this example. You see in both of these larger terms, x times x plus 2, 7 times x plus 2, you have a common factor of x plus 2. That's called a common binomial factor. And so I can distribute out that common binomial factor, bring it out to the front of the expression. And so I'm going to bring out the x plus 2, and so I'll have left over x. And then if I pull it out of the second term, I have 7. So x plus 7 would be the remaining terms after you distribute out x plus 2. So this ends up to be x plus 2 times x plus 7. All right. Here's another example, but we're starting more from it being in its raw form, you could say. Okay, so if I have x squared minus 5x plus xy minus 5y. Now, you notice that the first two terms have an x in them. The last two terms have a y in them. So we're going to group them together, sort of separate this into, two different distributing problems. So I'm going to distribute out an x here. So I'll have x times x minus 5. And in the second case, I'm going to distribute out a y. So I have y times x minus 5. And then if you notice, each of the terms, the bigger terms, has an x minus 5 in it. So I'm going to pull that x minus 5 out to the front, and then I'd have left over x plus y. So the complete factoring is this here. And if you FOIL that, you'll see that it equals the original expression that we had. Here's another example. So I got 3x to the third minus 2x minus 9x squared plus 6. Now, the first two terms have an x in them. So I could pull out an x, and that leaves me with 3x squared minus 2. The last two terms, the common factor is negative 3. Notice that first term is negative, so I'm going to pull out a negative of it. So negative 3, and then that leaves me with 3x squared minus 2. Because if I divide 6 by negative 3, you get negative 2. And so then you see that I have a common binomial factor of 3x squared minus 2. So I pull that 3x squared minus 2 out to the front, and that leaves me with x minus 3. So that is, the answer. Now, you could have also rearranged the terms. Some of you might have noticed that the terms are not in descending order. So we could rearrange the terms in descending order and then distribute out your greatest common factor. So in the first two terms, the greatest common factor is 3x squared, and then that leaves them with x minus 3. In the last two terms, we have a minus 2x and a 6. So if you distribute out a negative 2, you end up with x minus 3. Now, again, we have a common binomial factor, x minus 3. So we pull that out, x minus 3, and that leaves us with 3x squared minus 2. Now you notice that the problem answer is still the same. The only difference is the order of the parentheses. So you could rearrange the terms, but the order of the two parentheses that you end up with at the end might be different, but it's still mathematically the same, because it doesn't matter the order you have things in a multiplication problem, which is what we have, because these parentheses are multiplied together. Okay, one more example, and then you can try one here. So the common factor in the first two terms is just x. That's the only thing. So I could distribute out an x. So 5x squared divided by x would be 5x. So I'm going to have that for my first thing in the parentheses. Then I divide 4xy by x, and I get 4y. So I have that. And then in the last two terms, there's no number or variable that's in both, but I can always distribute out a 1 or a negative 1. So I'm going to use negative 1. So minus 1. And then I'll have left over 5x plus 4y. Okay. Oops. My y's aren't looking good. Okay. So now, do you notice that I've got 5x plus 4y? And another time I've got 5x plus 4y. So I'm going to pull that out to the front, if I can. 5x plus 4y. And notice I can pull that out to the front, and that would leave me with what's out in front of these, each of these. It would leave me with x and a minus 1. So x minus 1 is I already have a minus sign there, but anyway, so x minus 1 is the remaining terms after I pull out a 5x plus 4y. So I'm pause the video and try to do this one. Try to figure out how that one factors, and then we'll give you the answer. Okay, so I already showed the working of this problem here. So let's look at it. So in the first two terms, 3 is a common factor, and also x. So 3x is the greatest common factor. So if you divide 6x to the third by 3x, you get 2x squared. If you divide negative 15xy by 3x, you get negative 5y. In the last two terms, 4 is a common factor. So I'm actually, since the first term is negative, I'm going to use negative 4. And so I divide negative 8x squared by negative 4. I get 2x squared minus, and then 20y divided by negative 4 was negative 5y. Now, notice each of the binomials is the same. And if that's the case, if your binomials end up to be the same, then you can distribute that out. All right, we had an interruption there, but all right, so you notice that 2x squared minus 5y is in both of these larger terms, so I can distribute out 2x squared minus 5y out to the front, and that leaves me with 3x minus 4. So the complete factoring is that right there at the bottom. All right, now we're going to look at factoring a trinomial next, where the leading coefficient is a 1. So this would be where you have something like x squared plus something times x plus something at the end, where you have a 1 coefficient in front of the x squared. All right, so first notice that if you had a binomial x plus 3 times x plus 5, if you foiled that, you'd get x times x would be x squared. Outside terms would give us 5x. Inside terms would give us 3x. And then plus 3 times 5, or 15. And the 5x and the 3x would add up to the 8x. Now, we could have noticed this before. Whenever you have that number at the end, we're looking for the two numbers that multiply to give you that 15, that number at the end, but which add up to the sum of 8. So the factors that we're looking for are 3 and 5 because they multiply to give you 15 and add up to 8. So if we had to go backwards with this, that's what we would look for. Now, the formula for it is here. X squared plus some x plus the product. So that's what you do. You look for the factors of the last number that add up to the middle number. All right. Now I call this the Hebrew method because Hebrew, you read backwards. You start at, on the right side and go to the left. And so we're going to do that here. We're going to start with 10. Okay, what are the factors of 10? So you list the factors of 10, 1 and 10, 2 and 5. And of course, the pair that adds up to 7, the middle term 7, are 2 and 5. So then our binomials would be x plus 2 and x plus 5. All right? So if you FOIL that, you'll end up to getting the same trinomial that we started with, x squared plus 7x plus 10. All right? Now, we needed, in this case, both of them to be positive because everything was positive here. So we needed, both factors to be positive. But you got to be conscious of if there's a negative sign in there, what happens. So look at this next example. X squared plus 2x minus 35. Okay, so we're going to look for the factors of negative 35 that add up to 2. Now I listed the factors of negative 35, 1 and negative 35, negative 1 and 35, 5 and negative 7, 7 and negative 5. And of course, the pair that adds up to 2, positive 2, is the last pair here. So 7 and negative 5. So of course, to give you x squared, you got to have in the first positions x and x. But then after that, it's going to be a plus 7 in one of the binomials and a minus 5 in the other binomial. All right? So x plus 7 times x minus 5. Okay, in the next example, we have negative 10 for our last term, not positive 10, but negative 10. So you know that we got to have one positive and one negative. All right? And so we're looking for the factors of negative 10 that add up to negative 3. Oh, I didn't copy the line that had the other factors of negative 10. So the factors of negative 10 are 1 and negative 10, or you could have negative 1 and positive 10, or you could have 2 and negative 5, and you could have negative 2 and positive 5. Okay? Oops. That's a 5. All right, so we want the pair that adds up to negative 3. So, of course, that's this pair here, 2 and negative 5. So then, of course, we got to have x and x in our binomials, but we're going to have plus 2, and we're going to have x minus 5. All right, so it's that easy. Just look for the factors of the last number that add up to the middle coefficient. All right, some more examples. So x squared plus 2x minus 9. So you look for the factors of negative 9 that add up to 2. Well, the factors of negative 9 are 1, negative 9, negative 1, positive 9, 3 and negative 3, or negative 3 and 3. But they never add up to 2. The sum is always something else. And so since you cannot find any factors of the last number that add up to the middle coefficient, then this does not factor, all right, under the whole numbers anyway, does not factor, so we say it is prime. All right, so sometimes in the homework there'll be occasionally a problem where it doesn't factor. All right, now try to be careful about that, using that option. It's after you've tried all the factors of the last term. All right, assuming it's this case where you have a 1 in front of the problem. All right, here's another example. All right, so I've got x squared minus 9x plus 20. Now 20, that means positive 20. So if the last term is positive, the factors have to be either both positive or both negative, because both negative, when you multiply them together, that does give you positive 20. So if they're both positive, they would never add up to negative 9. So they must be both negative. All right, so you make that reason, you do that reasoning in your head and say, oh, I've got to have both of them negative, because if they're both positive, it would not add up to a negative. So if they're both negative, then here are my only factors: negative 1 and negative 20, negative 2 and negative 10, negative 4 and negative 5. Now I've systematically gone down here, starting with 1 and check for 2, and then 3 doesn't go into 20, and then 4 goes into 20. But as soon as I round my corner here, I don't have to look for any more factors. Those are all the factors. And so my pair I'm looking for is negative 4 and negative 5. So I put them in the binomials, and there's my answer right there. All right. So you try the next example. Pause the video and try this next example and see if you can correctly get the factoring with your parentheses and what goes in those binomials. All right. Okay, so in this example, we are looking for the factors of negative 12 that add up to negative 4. Now, you know, because it's the factors of negative 12, that one of them has to be negative and one has to be positive. But they have to add up to negative 4. So the bigger number needs to be negative. So I went over here and I listed the factors of negative 12 where the bigger number is negative. So 1 and negative 12, 2 and negative 6, 3 and negative 4. So the pair where the bigger number is negative and it adds up to negative 4 is the second pair, 2 and negative 6. So this would be x plus 2 and then x minus 6. Okay, so FOIL that, and you'll see that it equals the original trinomial. Now, sometimes the book will give you examples in the homework that where they have an extra variable in there. Like instead of just x, they have also a y variable. Now, I call this a tag-along variable because it just tags along at the end and doesn't really affect the factoring. It'll still factor, but you'll just have a y on the last terms. So you could actually remove the y's and do the factoring and then put them back in for the final answer. So in other words, if I pulled out the y here and the y squared here, it would be just x squared plus 8x plus 12, which you look for the factors of 12 that add up to 8. You get 2 and 6. So this is the factoring. So the final answer would be x plus 2y, because you got to stick the y back in there. Don't forget it. You know, you can temporarily remove it, but don't forget it. And then x plus 6y. All right. So we just temporarily pretended that y wasn't there and then put it in the final answer. If you FOIL that, you will get the original problem. All right, another example, we've got x to the fourth minus 9x squared plus 18. Now, this is a trinomial, and the only difference is this, you have x to the fourth power instead of x to the second power. Well, if you just make each of your first things in the binomials to be x squareds instead of just x's, then when you FOIL and do the first terms, x squared times x squared, that'll give you the x to the fourth power. All right, so what are the factors of 18 that add up to negative 9? Factors of 18 that add up to negative 9. Well, you could use negative 3 and negative 6. You know that both have to be negatives because they have to add up to a negative 9. So use negative 3 and negative 6. So the answer would be x squared minus 3, and x squared minus 6. So let's test this. FOIL it. Okay, first terms, x squared times x squared, that would give you the x to the fourth. Outside terms, x squared times negative 6 would be negative 6x squared. Inside terms, negative 3 times x squared would be negative 3 times x squared. So those are your two middle terms that you get. Of course, they add up to negative 9x squared, which is what you had in the original problem there. And then when I multiply the last terms together, negative 3 times negative 6 gives me my 18 that I wanted. All right? Okay, last example, it's very similar. To get b to the fourth, we would just use b squared and another b squared. All right, so we put those in the parentheses in the first positions. All right. Now, what are the factors of 5 that add up to 6? Well, 5 and 1. So it'd be b squared plus 5 and b squared plus 1. All right. Now, often you have to do that first step of distributing out your greatest common factor before you can do the factoring we were just talking about. So here's an example of that. So you have these three terms, and you see that 5 goes into everything. So I can distribute out a 5, and if I divide everything by 5, I'd get x squared plus 2x minus 8. Okay, then because we have now a 1 in front of the x squared term, I can use the Hebrew method where I start and the factors of negative 8 that add up to 2 are positive 4 and negative 2, right? They add up to 2, but they multiply to give you negative 8. So then this would be 5 times x plus 4 and x minus 2. Okay? So notice we first distribute out a 5. and then look at what we have. Don't try to do the factoring until you've done that first step of distributing out the 5. Then you can see what you have and figure out how to factor it after that. Okay, the next example, first of all, you notice it's not written in descending order. So the first thing you could do is, replace it and put it in descending order. So 2t to the second power, and then plus 20t, and then plus 50. All right. Now, obviously, what goes into everything? Well, a 2. So I can pull out a 2, distribute out a 2, and that leaves me with t squared plus 10t, and then plus 25. Apologize, I can't fit this. So 2 times parentheses t squared plus 10t plus 25. So now, what are the factors of 25 that add up to 10? Well, 5 and 5. So we're going to have basically t plus 5 and then t plus 5 again. Now, when we have the same binomial twice, like t plus 5 times t plus 5, I could, after I put the 2 down, which we have to continue to write, then I could write t plus 5 squared. I could put an exponent on the outside of this, and so 2 times t plus 5 squared, because that's what t plus 5 times t plus 5 could be written as, that binomial squared. All right, and the last example here, what goes into everything? Well, I know that 3 goes into all those, and then also I have x to the 4th power, because this has 6, this has 5, this has 4. Whichever has the least is what limits you, so 3x to the 4th. Now, if I divide everything by 3x to the 4th, this is going to be x squared. Negative 30 divided by 3 is negative 10, so I'll have negative 10. And if I take 4 of them out of 5 of them, I'll have 1x left over. And then 72 divided by 3, let's see, that would be what? 24. So plus 24. So now, after we do that step, then we look and see what we got. Okay, we can try the Hebrew method because we have a 1 in front here, and then we can look for the factors of 24 that add up to negative 10. So the factors of 24 are either both positive or both negative, but both positive is not going to work because it has to add up to negative 10. So I have to have both negative. And so both negative that add up to negative 10. So what would be factors of 24 that add up to negative 10? Well, it would be negative 4 and negative 6, wouldn't it? Because they multiply to give you 24, but they add up to negative 10. So then the binomials would be x minus 4 and then x minus 6. All right. So that's the complete factoring for this problem. So now we're going to look at factoring a trinomial where the leading coefficient is not a 1. So this would be a polynomial such as this right here, 2x squared plus 7x plus 6, for example. And what we want to do here is use what's called the AC method. So it's called the AC method because the first thing you do is you multiply the outer terms. You multiply, in this case, you're going to multiply the 2x squared and the 6, and that'll give you 12x squared. All right, then step 2, you're going to split this product into two factors that add up to the middle term. So the middle term is 7x. So how can we split up 12x squared so that it adds up to 7x? Well, I can split up 12x squared into 4x and 3x because they multiply to give you 12x squared, but they add up to 7x. That's what you do. 4x, 3x, that you find two things that multiply to give you this product of 12x squared, but add up to the middle term. All right, then you rewrite the polynomial. You'll notice what I did here is I rewrote the polynomial with that 7x split up into 4x and 3x. And then I use factor by grouping. So I'm going to group together the first two terms here and take out a common factor. So 2x goes into both of them, leaving x plus 2. In the last two terms, 3 goes into both of them, leaving x plus 2. And then since we have the same binomial factor, x plus 2, that you see in both of the bigger terms, I can pull that out, I can distribute that out, and then that leaves me with 2x plus 3. All right? So we just did factor by grouping to finish this off and to get our answer, which is this x plus 2 times 2x plus 3. Here's another example. So suppose you have 5x squared minus 8x minus 4. Well, the first thing you do is you multiply your outer terms, your a and your c terms. So 5x squared times negative 4 would be negative 20 and then x squared. Negative 20x squared. Now, what are the factors of negative 20? Well, I did them over here. Factors of negative 20, you could have, negative 1 times 20, negative 2 times 10, negative 4 times 5, or where you flip the sign on those. But we want the pair that would add up to negative 8x, or negative 8. Well, it's this pair right here, 2 and negative 10. They add up to negative 8. So I'm going to rewrite this using 2x and negative 10x. Okay? Don't 2x and negative 10x add up to negative 8x? So I can rewrite the trinomial as this, 5x squared plus 2x minus 10x minus 4. And then I'm going to use factor by grouping. So in the first two terms, the common factor is x. So if I pull out an x, that would leave me with 5x, and then pull the x out of 2x, and you'd have just 2. So 5x plus 2. And in the last two terms, the common factor, well, 2 goes into both of those numbers, but I want to use negative 2. I want to go ahead and pull out a negative 2. So if I divide negative 10x by negative 2, that would leave me with positive 5x. I'm having trouble with my writing tool here. So positive 5x. And then if I divide negative 4 by negative 2, negative 4 divided by negative 2 is a positive 2. All right? So if you notice, I've got 5x plus 2 and 5x plus 2. So I can distribute out 5x plus 2 out of both of the bigger terms there. Okay, so if I pull it out of the first term, it's like I'm canceling it out. I'll have left over an x. So I put x here. And then when I take it out of the last two terms, I'm going to have a minus 2. So minus 2. So the complete factoring is 5x plus 2 and x minus 2. And if you FOIL that, you'll find that it equals the original problem. Okay, in the next example, you have 10x squared minus 13xy plus 3y squared. Now you can see that there's no common factors. You can't distribute out a greatest common factor. There's nothing that's in all three terms. So because you do not have a 1 in front, you will have to use the AC method. Okay. Now you could temporarily remove that tag along variable and just add it back later, but I'll just do it the way it is. So the first thing you want to do is multiply the outer term. So what's 10x squared times 3y squared? Well, that would be 30 x squared y squared. All right, 30x squared y squared. Now, what are the factors of 30x squared y squared that add up to negative 13xy? Well, you know that they both have to be negative, right? They can't be both positive. They have to be both negative to give you negative 13. And so we would have to use negative 3x squared y and negative 10xy. Negative 3xy and negative 10xy. So that's how we'll split up the negative 13xy. Okay, so I've rewrote the polynomial. Instead of a minus 13xy here for the middle term, I rewrote it as negative 3xy and negative 10xy, of course, which adds up to negative 13xy. And now I'm going to distribute out the greatest common factor out of each of the first two terms, and then out of the last two terms. So I know that x will go into both of the first two terms, so that'll leave me with x parentheses 10x and then minus 3y. And then in the last two terms, there's a y in both terms. And since that first term is negative, I'm going to distribute out a negative y. And so if I pull out a negative y, you have left over 10x. Sorry. And then if I divide 3y squared by negative y, you'd have negative 3y left over. Oops. Right? So as you can see, you have the common binomial, 10x minus 3y, that you can pull out of each thing. So my final answer would be 10x minus 3y. That's the common binomial that you're going to distribute out of each of the bigger terms. If I pull it out of the first big term, I have left over x. So I'll put that in the second parentheses. And then if I pull it out of the last term, I'll have a minus y. So that's the factoring right there. 10x minus 3y, and then parentheses x minus y. Right? Now, the last example here on this page, the first thing I did was distribute out a negative 1. You don't have to do this, but I think it's helpful. But after you take out the negative 1, you still have a 6 for the leading coefficient, so we're going to use the AC method. So the AC method, let me draw a line here. The AC method would have us first multiply the outer terms, so 6x to the second, and times negative 5 is negative 30x squared. And then you have to break up negative 30x squared into two factors, one of them positive, one of them negative, that add up to 13. Now don't use 3 and 10 because again, one has to be positive, one has to be negative. So I believe the correct way to break that up is split it up into negative 2x and positive 15x. Okay? Because those two expressions, negative 2x and 15x, add up to positive 13x. So we'll basically take what's in parentheses and rewrite it with negative 2x plus 15x in the middle instead of 13x. And then you'll just do the factoring by grouping that final step that you'll distribute out the common factors like I just did here. And so your final answer, well, you go ahead and pause the video and then I'll tell what the final answer is. All right, so the final answer, well, you should have the -1 that we had originally. You should have 2x plus 5 in the first binomial. And then the last binomial will be 3x minus 1. So if you got that, then you're doing pretty good, pretty well. So just if you're not getting that, then you might need to come in for some tutoring or set up an online meeting with me. But that's called the AC method. All right, so the next thing in the factoring area is special forms. These are special polynomials and how they factor. Now, in the first case, you have what's called perfect square trinomials. There's the one where it's all positive, or there's one where you have a negative middle term. If you have things in these two forms, then they will factor as the product of binomials, as a plus b, or a plus b squared, or a minus b, which is a minus b squared. Or if it's a binomial, you may have a squared minus b squared, which is called a difference of squares, in which case it factors as a plus b, a minus b. All right? So in the first case, you have x squared plus 6x plus 9, that first example. Now that's in the first form. We know this because the first term is a square, x squared. The last term is a square. Isn't 9 3 squared? And then the middle term is 2 times the product of the first thing, x, and the last thing, 3. Because 9 was 3 squared. All right? Notice it has to be 2ab. In this case, b is 3. So here's what you would do. So you got this trinomial. You would say to yourself, okay, that fits the form because the first and the last terms are squares, and the middle term is 2 times the first thing that was squared times the last thing that was squared, which is 3. And that's the case because it's 6x. So that fits the form, and so it factors according to the a binomial squared, x plus 3 squared. Now you could have used the Hebrew method and said to yourself, well, what are the factors of 9 that add up to 6, which are 3 and 3? So it would be x plus 3, or x plus 3 squared. But I'm trying to show you the pattern and be able to use that. All right, so the next thing has a negative sign for the middle term. And this one uses the middle pattern, the second pattern, and you can fit it into the form of the first thing squared minus 2 times the first thing times the second thing plus the last thing squared. And that fits the form because this is a negative 10x as it should be, and the 25 is 5 squared. So your A and your B are x and 5. So this is a minus b squared, or x minus 5 squared. All right. In the next example, it's kind of out of order. I would take this polynomial and rewrite it in the proper order. Make it 49b to the fourth. So put that term first, and then plus 14b, and then plus 1. So I would put it into descending order, but you don't have to. But all right, so then ask yourself, is this a perfect square? Well, the first thing is 49. That's a perfect square, 7 squared. B to the fourth could be thought of as b squared squared, and 1 is a perfect square. So you kind of think to yourself, okay, what squared would give me the first term? And what squared would give me the last term? Well, 7b squared, when I square that, that gives me 49b squared. And 1 squared is 1. So this is my 7b squared is the A, and 1 is the B in the first form up here. So does the middle term equal the product of 2 times AB? Well, yes, because 2 times 7b squared times 1 is equal to 14b squared. This should be b squared here as in the original. All right? So it fits the pattern for the first one. So we could just say, all right, it's what squared? Just go right to the end of the formula here, and it would be 7b squared. That's the A plus 1, because that's the B, because we're just doing A plus B squared. All right. In the next example, y squared minus 16. Well, this is in the form of a difference of squares, a squared minus b squared. And so the factor, what squared gives you 16? Well, that's 4. So it's y plus 4, y minus 4, according to the pattern. In the last example, what squared would give you 9z squared? Well, it would be 3z squared would be the same as 9z squared. And what squared would give you 49? Well, that would be 7 squared. So now we have it in the form of a squared minus b squared. And so we're going to write a plus b times a minus b. So my a is 3z here. So I'll have 3z plus the b. Well, the b is 7, so 3b plus 7. And then 3z minus 7. Right? So that's the final factoring there. It's a difference of squares. Now, the factoring flowchart, that is a document up on Canvas that you can look at, the full document, starts off with asking you, okay, combine any like terms and arrange them in descending order. Then, as I mentioned before, you're going to check for common factors. If there is a common factor, you'll distribute it out. So here I've got an example. I distributed out 3x, and that left me with x squared minus 4. Now, after you do the distributing out to greatest common factor, then secondly, check, is the result a binomial? Now, in this case, it is. X squared minus 4 is a binomial. And so you'll check for the next thing. Is it a difference of squares? Well, in this case, yes, it is. X squared minus 4 is a difference of squares. And so this factors as x plus 2, x minus 2. All right? X plus 2, x minus 2. So that's the complete factoring. So after you do the first step, you've got to check for other steps and see if you can continue to factor. All right. Now, there's also a sum or difference of cubes. They're a little bit more complicated. I showed an example here for that, but I'm not going to take time and look at that. But anyway, so then after you've checked, is it a binomial? If it's not a binomial, you skip down to, is it a trinomial? If it's a trinomial, then we'll look at some other things. And so let me switch to the next slide, and then we'll look at it. All right, in this slide, you see that the remainder, the bottom half of the factoring flowchart is for if it's a trinomial. Now, if it's a trinomial, you'll check, is 1 the leading coefficient? And if so, it would be something like this. Example, x squared plus 4x minus 21. And so you could use the Hebrew method where you look for the factors of negative 21 in this case that add up to 4. So the factors of negative 21 that add up to 4 are 7 and negative 3. So it factors as x plus 7 times x minus 3. All right. Now, if you do not have 1 to be your leading coefficient, so if the leading coefficient is not 1, then we got to use the AC method. All right. This AC method. So I have an example over here on the left margin. And we've worked a few of these already, but just, multiply the outer terms, split up that product into two factors that add up to the middle term. So negative 1x, negative 4x and 3x add up to the negative 1x. And then factor the first two terms and the last two terms separately. And then if you get a common binomial like x minus 2 here, we can pull that x minus 2 out to the front. All right. And then if the AC method is not working, then you could try the is it a perfect square trinomial or not? So there's two patterns. The one we did was a plus, or one had a minus, and this is an example of that. All right. And then if there are 4 or more terms, we'll try to use factoring by grouping. All right. All right, so that was a discussion of how to factor polynomials. Now, polynomials, they can be part of an equation. They don't have to be. They could just be standalone. They could factor them, and then that's it. You just factor it and leave it. Or they could be part of an equation. And so one use of factoring is to solve quadratic equations, or even cubic equations or higher, using factoring. So let's see how you would do this. Now, first of all, what is a quadratic equation? Well, it's any equation where the highest degree term is a squared term. This is a degree 2 term, right? This highest degree, ax squared. So an example would be here, 5x squared minus 3x plus 9 equals 0. The highest degree term is degree 2, and so that makes this a quadratic equation. Now you want to have all the terms in descending order on the same side of the equation. So this equation, this first one, 5x squared minus 3x plus 9 equals 0, is in standard form. Standard form has to have all the terms on one side and in descending order. Okay. Now in this second equation here, this is not in standard form. The reason is it's not in descending order. Okay. We would put it into standard form if we would move that 5 to be near the end of the trinomial. So we'll have negative 3x squared. We'll put our minus x next, and then we'll put our plus 5, and then we'll have equals 0. Okay, so that is in descending order. That's in standard form. That's an important thing that you do that first. I see students all the time getting messed up because they don't do that first step. Okay, the next example, is that in standard form? Obviously not. And so we just need to move these two terms over to the right side. Okay, and then we'll have 0 equals 2x squared, and then minus 7x, and I move the negative 8 over, it becomes plus 8. And you might wonder, well, why did I move the 7x and the minus 8 over to the right side? Why didn't I move the 2x squared over to the left side? Well, actually, I don't like to have my leading term, my squared term, negative. I like to have it positive. Now, in the first case, I didn't bother to do that because we were just switching these two terms around here. We were just switching the 5 and the minus x, and I didn't bother to do it there. But here, if I'm going to move something over, I might as well just get it so that the highest degree term, my squared term, is positive. Okay. All right. So then in the example here in letter B here, what we're doing is the complete steps to solving this quadratic equation by factoring. All right. So suppose your equation begins like this right here. First thing you got to do is put it in descending order. So I'd start with my x squared term, and then I'd put my 3x, and I have to move this 4 over to the left side. So I have to make it negative 4. So x squared plus 3x minus 4 equals 0. All right, so the first step, put it in the standard form. Second step, factor completely. Factor the left side of the equation, or whichever side has the terms, factor that completely. Now, I can use the Hebrew method because I have a 1 in front of the polynomial. And so the factors of negative 4 that add up to 3 are positive 4 and negative 1. So I'm going to put it in my parentheses, go x plus 4, x minus 1. Okay, now I'm going to use what's called the zero product property. All right, let me write the zero product property. Okay, I wrote the zero product property over on the left side here. It says if A times B equals 0. So if I have a product equaling 0, then either the first thing, A, was 0, or the second thing is 0. Or it could be both, but at least one of those has to be 0, right? Or either one can be 0. So that's what I'm going to use right here. I've got the product of this and this equaling 0. So either the first thing, x plus 4, is equal to 0, or the last thing, x minus 1, is equal to 0. Well, that gives me two little equations that I can then solve. So if I solve the first equation, well, I'd subtract 4 from both sides, and I'd get x is negative 4. Or in the second equation, I'd add 1 to both sides, and I'd get x equals positive 1. So that gives me the solutions to this equation. And if you take either of these two numbers and plug that number in for x into the original equation, then that will give you, it'll work. It'll equal on both sides. So it'll be a solution to that equation. All right, so let's look at another example here. If we have x squared equals 8x minus 15, so that's not in standard form, obviously. So I want to put it in standard form. I'm going to start off with x squared, and I've got to move that 8x. See, I've got an 8x, but it's on the right side of the equal sign. Here's your equal sign right here. Okay, so you've got to move that 8x over. So when I do, it'll become negative 8x, right? And then if I move the negative 15 over, that will become positive 15. Okay, so the equation then is x squared minus 8x plus 15 equals 0. All right, so I've got it in standard form. I have to have everything on the left side equals 0, or on the right side, but I moved it over to the left side on this case. All right, now we've got to factor this completely. So because we have a 1 in front, we can use the Hebrew method. We can say, okay, what are the factors of 15 that add up to negative 8? Well, that would have to be what? Negative 3 and negative 5. So it factors as x minus 3 and x minus 5. Okay? But we're not ready to say what x is yet. We're just saying that I can factor this trinomial into these two binomials, and then it equals 0. All right, so now we can split this up into two little equations. So I can say either x minus 3 equals 0, or I can say x minus 5 equals 0. Okay. Now, in solving the first equation, I would add 3 to both sides, so I'd get x equals 3. In the second equation, I would add 5 to both sides, so I'd get x equals 5. So the two solutions to this equation are 3 and 5. And if you try either of those two numbers in to the original equation, then it should work. All right. And next example, first step, get it into standard form. So I'm going to move the terms on the right side, I'm going to move them over to the left. So I'll have the 2x squared on the left side to begin with. That's staying where it was. And then I'll have minus 18x because I moved it over to the other side, so it becomes the opposite of what it was. And then I have a negative 28, but I'm going to move it over to the left side, so it'll become a positive 28. And then all of that equals 0. Oops. All right. I'm having trouble writing. All right. So now I look at it and say, okay, now I got a factor. Now I've got a 2 in front here, but I haven't done my first step in factoring. I haven't distributed out the common factor. So the first thing I'm going to do is distribute out a 2. And that leaves me with x squared, and then minus 9x, and then plus 14. All of that equals 0, or in parentheses, and then equals 0. But I'm not done factoring because I've got this trinomial inside the parentheses. And so how does that factor? Well, what are the factors of 14 that add up to negative 9? Well, they both have to be negative. And so try negative 2 and negative 7. So negative 2 and negative 7 would work. So I'll go x minus 2 and then x minus 7. All right. Oops, I tried to make that parentheses there. And then equals 0. So I've broken up my trinomial into those two binomials. Now I'm ready to split it up into my two little equations. So I have that 2 out in front. Now that 2 doesn't do anything because it doesn't have an x in there. If it had an x in that, if it was 2x out in front, in other words, then I'd set it equal to 0, but I don't need to do that because 2 can never equal 0. Just plain 2 is always 2. It's never going to equal anything else. But I can take this x minus 2 and set that equal to 0. So I say x minus 2 equals 0. And so if I add 2 to both sides, that will give me x equals 2. And then I have x minus 7 equals 0. And so, oops. Oh, man. Looking like a first grader writing. All right, and then I add 7 to both sides, so I get x equals 7. All right, so 2 solutions to a lot of these equations. All right, now sometimes it could be negative numbers, but this time so far I've got positive numbers. All right, so now some more examples, and then we'll be done with this unit. All right, so in my example here, I do not have it in standard form. I have to have everything on one side and 0 on the other side. So I'm going to put 5x squared, but then when I move the negative 15x over, it'll become positive 15x. And all of that equals 0. So that's what I did first. I moved this negative 15x over. Now, the first step in factoring is checking for common factors. So the first two terms, the terms have a common factor of 5x. So I'll write 5x, parentheses, and then I'll have x plus 3, and then equals 0. Okay, now I've got the product of two things equaling 0. 5x times x plus 3, the product equals 0, so I can split that up, and I can say either 5x equals 0 or x plus 3 equals 0. Now, in the first case, this is multiplication, so the opposite of multiplying is dividing. So I would divide both sides by 5, and so x is going to be 0 divided by 5, but 0 divided by 5 is just 0. So first I have x is 0. In the second equation, I would move the 3 over, so x equals negative 3. All right, so my two solutions are 0 and negative 3. In the next example, I have to put in the standard form, so I'm going to start off with my x squared term. I'm going to move the negative 9x over, and it'll become plus 9x. Put that in the middle. Okay. And then plus 20. I didn't move the 20. The 20 is still on the left side like it was in the beginning, so it's still positive 20 equals 0. Okay. Now, because we have a 1 in front, we can use the Hebrew method, and we can look for the factors of 20 that add up to 9. Well, 4 and 5. So in my parentheses, it would be x plus 4 and then x plus 5. Okay? And then equals 0. Now, I'm going to set each binomial equal to 0, so I'll say x plus 4 equals 0. Oops. I meant to say x plus 4 equals 0. And then move the 4 over, so I get x equals negative 4. In my second equation, I write x plus 5 equals 0. And so move the 5 over, so I get x is negative 5. So my two solutions this time are both negative, negative 4 and negative 5. All right? Here's some more examples. Why don't you pause the video and try to do these the first example here. The second example is a little tricky because it, well, uses the AC method, but you should be able to do the AC method. But anyway, try the first example. Okay, in this example, the first thing I did was move the 18 over to the left side. So I get x squared minus 3x minus 18 equals 0. And so then I look for the factors of negative 18 that add up to negative 3. So one of them has to be negative, one of them has to be positive. And so negative 6 and positive 3 will work because negative 6 and positive 3 multiply to give you negative 18, but they add up to negative 3. So that's how it factors in the binomials. Then I use the zero product property and I split it up and I say x minus 6 equals 0 or x plus 3 equals 0. In the first case, move the 6 over so x is positive 6. In the second case, move the 3 over so you get x equals negative 3. All right. So then the next example, I would recommend everything being moved over to the left side so that your 2x squared term is positive. But go ahead and pause the video and try that. Okay, in this second example here, first thing I did is I moved the negative 2x squared to the left side and became positive 2x squared. I also moved the 7x to the left side, but it becomes negative 7x. And then I have the 3 already over on the left side, so I don't change the sign on that. So I just have 2x squared minus 7x plus 3 equals 0. Of course, when you move everything over, there's nothing left on the right side, so it'd be just equals 0. And because I don't have any common factors and I have a number that's not a 1 in front, then I've got to use the AC method. So I start by multiplying the terms on the outside. So 2x squared times 3 is 6x squared. And then I got to split that up so it adds up to negative 7x. So if you split it up into negative 6x and negative 1x, that adds up to negative 7x. And so we can rewrite the polynomial as I did here. And then I want to search for common factors. So in the first two terms, the common factor is 2x. So what I did next is up here. I did 2x times x minus 3. And then the common factor of the last two terms was just 1. So I actually distributed out a negative 1. So you see I've got negative 1 and then parentheses x minus 3. Because if you divide 3 by negative 1, you get negative 3. So then I have a common binomial factor, x minus 3. That's in both of the bigger terms. And I pull that out to the front. So I've got x minus 3. And then in parentheses, what's left over, I've got 2x and a minus 1. So the factoring is x minus 3, 2x minus 1. And then I split it up into my little equations using the zero product property. And I get x minus 3 equals 0, or else x is 3. And then 2x minus 1 equals 0. And if I move the 1 over to the other side, I get 2x equals 1. And then divide both sides by 2. And so x is 1/2. So the two answers for this one are 3 and negative 1. I'm sorry, and 1/2. Now, whenever you have the AC method involved and you're solving a quadratic equation, you're going to get a fraction for at least one of your answers. So be aware of that. All right. In the last example, it's kind of got things on both sides. So we want to combine some terms, move everything to the same side. So what I would do is subtract 3x squared from both sides. And also let's move the 8x over to the right side. So we end up with 0 equals, I subtract 3x squared from both sides, that'll be 3x squared, because 6x squared minus 3x squared is 3x squared. And if I add 8x to both sides, 8x added with the 4x is 12x. So I get 0 equals 3x squared plus 12x. All right. Now I factor on the right side, but the first step in factoring is distributing out your greatest common factor. So I would first distribute out 3x out of this. I'm having trouble writing this. So I would go 3x and then parentheses x plus 4. Right? So that is completely factored. And then I'll break it up using the zero product property. And so I'll set 3x equal to 0. And I'll set x minus 4 equals 0. I'm sorry, x plus 4 equals 0. Let me draw a line here separating these two problems. Okay, and then in the first case, I would divide both sides by 3, and 0 divided by 3 is still 0. And in the last case, I would subtract 4 from both sides, so x would be negative 4. So my two solutions for the third problem are 0 and negative 4. All right? 0 and negative 4. And if you try either one of those numbers into this equation, it should work. All right? So that's done. We've covered all kinds of factoring that you'll see in this class, and we've covered using factoring to solve equations. Now, there's other uses for factoring besides solving quadratic equations, but this is a key type or usage for factoring is solving quadratic equations. So I hope this helps you to be able to do the homework. Let me know if you have questions.